Welcome to the video. Today we are talking about every single type of galaxy. Watch to the end to learn about green pea galaxies, fossil galaxies, ram pressure galaxies, and jellyfish galaxies. Alright, let's start with theoretical galaxies. Bose-Einstein condensate galaxies are galaxies that are proposed to consist of a cloud of cold, dense gas made up of particles that have undergone Bose-Einstein condensation. In this state, the particles lose their individual identities and form a single entity that behaves like a single wave. Bose-Einstein galaxies are predicted to form in the early universe, where the gas is cold and dense enough to undergo Bose-Einstein condensation. These galaxies may have unique properties, such as a lack of density fluctuations and a low degree of entropy. Firehose instability is a theoretical concept in astrophysics that may occur in galaxies with magnetic fields, specifically in the context of the interstellar medium. The instability is thought to arise from the interaction between the magnetic field and the interstellar medium gas, resulting in a spiraling of the field lines around the axis of the galaxy. Fuzzy dark matter galaxies are characterized by a core halo structure with a large, fuzzy core and a small, dense halo. Fuzzy dark matter is a form of dark matter composed of ultralight bosons. The fuzzy core arises due to the wave nature of fuzzy dark matter particles, which causes them to have a non-zero de Broglie wavelength. A dark galaxy is a hypothetical type of galaxy composed of dark matter, with little or no visible matter. Unlike regular galaxies, which are composed of both visible matter, stars, gas, and dust, and dark matter, dark galaxies are thought to consist entirely of dark matter. Some evidence for their existence has been inferred from observations of the gravitational lensing of light from distant galaxies, which suggests the presence of massive, dark objects that could be dark galaxies. There are three types of dark galaxies or dark matter galaxies: cold, warm, and hot. Each form in different ways depending on the properties of the dark matter particles that make up the majority of their mass. Cold dark matter galaxies are thought to form through the hierarchical clustering of dark matter in the early universe. Cold dark matter particles are slow-moving and non-interacting, allowing them to form dense structures through gravitational interactions. Small, dense dark matter overdensities form first, which then merge to form larger structures like galaxies and galaxy clusters. The visible matter, stars, gas, and dust, follows the distribution of dark matter, settling into the gravitational potential wells created by the dark matter. Warm dark matter galaxies are similar to cold dark matter galaxies, but with a smaller mass range for the dark matter particles. Warm dark matter particles are thought to have intermediate velocities. Warm dark matter may have a smoother density profile compared to cold dark matter, leading to a suppression of small-scale structure in the early universe. This would result in the formation of low-mass galaxies and their properties. Hot dark matter galaxies are thought to form through the collapse of the densest regions of dark matter, where the dark matter particles are relativistic and move at high velocities. Hot dark matter particles are much lighter than cold dark matter or warm dark matter particles and can move at speeds close to the speed of light. White hole galaxies are a hypothetical type of galaxy that are thought to be the opposite of black hole galaxies. While black holes are regions of space where gravity is so strong that nothing can escape, a white hole is a region of space where nothing can enter, but everything that goes in is ejected back out. Some theories propose that white hole galaxies could form from a cosmic bounce, where the universe undergoes a sudden phase change, reversing the flow of time and leading to the formation of a white hole. Fossil galaxies are a type of galaxy that have stopped forming stars and have fossilized into a state where they have little to no ongoing star formation activity. These galaxies are often identified by their old stellar populations and lack of gas and dust. A rogue galaxy, also known as an orphan galaxy, is a galaxy that is not gravitationally bound to a larger galaxy or galaxy cluster. These galaxies are thought to have been ejected from their original group or cluster through gravitational interactions with other galaxies or dark matter. Rogue galaxies are difficult to detect, as they are isolated and often do not emit significant amounts of light. Alright, let's talk about the different parts of a galaxy. Ultracompact high-velocity clouds are a type of gas cloud characterized by their small size with less than 1 kiloparsec in diameter and high velocity relative to the surrounding interstellar medium, with typical velocities in the range of 100 to 200 km/s. A quasar is an extremely luminous and energetic active galactic nucleus that is powered by a supermassive black hole at the center of a galaxy. Quasars emit vast amounts of energy across the electromagnetic spectrum, from radio waves to gamma rays. A stellar disk is a flattened, rotating component of a galaxy, composed mainly of stars and gas. It is shaped like a disk or a pancake and has a thickness much smaller than its radius. In a spiral galaxy, the stellar disk contains the spiral arms that give the galaxy its characteristic shape. The stars in the disk are generally younger and bluer than those in the central bulge of the galaxy, and they follow orbits that are mostly circular, lying in the plane of the disk. A bulge refers to the central, roughly spherical region of a galaxy, typically located above or below the plane of its flattened disk. The bulge is usually composed of older stars and has a higher density than the surrounding disk. In some galaxies, the bulge is also associated with a supermassive black hole at its center. Bulges can take on different shapes. Globular clusters are dense, spherical collections of stars that orbit around the center of a galaxy. They are composed of hundreds of thousands or even millions of stars, which are gravitationally bound together and move as a single entity. Globular clusters are typically found in the halos of galaxies and are among the oldest structures in the universe, with ages of up to 13 billion years. A halo refers to the outermost region of a galaxy, extending far beyond the disk and containing a large fraction of the galaxy's mass. The halo is usually composed of a mixture of dark matter, old stars, and globular clusters, and has a lower density than the central bulge or the disk. Dark matter halo. A dark matter halo is a theoretical structure that is thought to surround galaxies and other astronomical objects, composed primarily of dark matter. Dark matter is a type of matter that is not directly observable through electromagnetic radiation, but whose presence is inferred through its gravitational effects on visible matter. Dark matter halos are believed to provide the majority of the gravitational pull that holds galaxies together. Dark matter is thought to make up most of the mass of a galaxy. Spiral arms are prominent features in spiral galaxies, consisting of bright, young stars that form long, curving arms extending from the central bulge. The stars in the arms are often blue and massive, and are surrounded by clouds of gas and dust that are actively forming new stars. The shape and number of spiral arms vary between galaxies, with some having two prominent arms while others have multiple or even a single arm. Spiral arms are believed to be the result of density waves propagating through the disk of a galaxy, causing regions of enhanced star formation and gas compression as they pass through. The interstellar medium is the matter and radiation that exists in the space between stars and a galaxy. It is composed of a variety of components, including gas, mostly hydrogen and helium, dust, cosmic rays, and magnetic fields. The gas in the interstellar medium can form new stars through the process of gravitational collapse, and the dust plays an important role in the absorption and scattering of light, as well as the formation of planetary systems. Stellar streams are long, thin, and diffuse structures of stars that can be observed around some galaxies. These structures are thought to have formed from the tidal disruption of smaller galaxies or star clusters that have been absorbed by the gravitational pull of the host galaxy. As the smaller objects approach the larger galaxy, they are stretched out into long, narrow streams of stars, which can be observed through their gravitational influence. Dust lanes are dark, elongated features that are observed in the disks of some galaxies. They are composed of dust and gas, which absorb and scatter visible light, creating dark, opaque regions that appear as lanes. The dust lanes are typically located within or near the spiral arms of a galaxy, and they can be seen as prominent features in images of galaxies taken in the visible and infrared wavelengths. The dust lanes can affect the motion of gas and stars within the galaxy and influence the process of star formation. Loops and streamers are structures that are observed in some galaxies, particularly those that have experienced tidal interactions with other galaxies or dark matter halos. These structures are composed of stars and gas that have been stripped from the galaxy by tidal forces, and they can appear as elongated and irregular features in the outer regions of the galaxy's disk. The loops and streamers are thought to be formed as the stars and gas are pulled out of the galaxy and are stretched out by the gravitational forces of the interacting objects. Subgalactic clumps are compact and massive structures that are found within galaxies or in the outskirts of galaxy clusters. These clumps are typically composed of dark matter and gas, and they can have masses ranging from a few million to a few billion times that of the Sun. The subgalactic clumps are thought to form through a variety of processes, such as the collapse of gas clouds, the merging of smaller galaxies, or the fragmentation of the interstellar medium within a galaxy. Alright, here's some of the main types of galaxies. Spiral galaxies are a type of galaxy characterized by a distinctive spiral pattern of arms that extend outward from a central bulge. The arms are typically composed of young, bright stars, as well as gas and dust that are actively forming new stars. The central bulge is usually more compact and composed of older stars that have already exhausted their fuel for star formation. Spiral galaxies are thought to form from the gravitational collapse of gas clouds, which then rotate and flatten into a disc-shaped structure. The spiral arms are then formed as the gas and stars in the disk are gravitationally pulled by density waves, which compress the gas and trigger the formation of new stars. Elliptical galaxies are a type of galaxy characterized by a smooth, elliptical shape, rather than the spiral arms seen in spiral galaxies. They are typically composed of older stars that have already exhausted their fuel for star formation, with little to no ongoing star formation activity. Elliptical galaxies are thought to form through the merging of smaller galaxies, which triggers a burst of star formation activity. Irregular galaxies are a type of galaxy that do not have a regular or symmetric shape and lack the organized structures seen in spiral or elliptical galaxies. They are often composed of young, bright stars that are actively forming, as well as gas and dust that provide the raw materials for ongoing star formation. Irregular galaxies are thought to form through a variety of processes, such as tidal interactions between galaxies, gravitational disturbances, or the merging of smaller galaxies. Lenticular galaxies, also known as S0 galaxies, are a type of galaxy that has characteristics of both spiral and elliptical galaxies. They have a central bulge like an elliptical galaxy, but they also have a disk of stars and gas like a spiral galaxy. Unlike spiral galaxies, lenticular galaxies have very little gas and dust, and very little ongoing star formation. They are often found in the centers of galaxy clusters, where they are thought to be the result of interactions between galaxies that have stripped away their gas and disrupted their spiral structure. Dwarf galaxies are small galaxies that contain only a few million to a few billion stars. They are much smaller and less massive than typical galaxies. Dwarf galaxies may contain significant amounts of dark matter. Dwarf galaxies come in two main types: dwarf spheroidal galaxies and dwarf irregular galaxies. Dwarf spheroidal galaxies are usually found in clusters or near larger galaxies, and they have very little gas or ongoing star formation. Dwarf irregular galaxies, on the other hand, are often isolated and have more gas and ongoing star formation. Ring galaxies are a type of galaxy that are characterized by a bright ring-like structure surrounding a central core of stars. The ring is composed of hot, young stars that are very bright in ultraviolet and visible light. In contrast, the core of the galaxy is composed of older stars that are not as bright. Ring galaxies are thought to form through a rare type of collision between two galaxies, where one galaxy passes through the center of the other galaxy. Barred spiral galaxies are a type of galaxy that have a central bar-shaped structure that runs through their spiral arms. The bar is composed of stars, gas, and dust, and it is thought to be a result of gravitational interactions between the stars and gas in the galaxy. Active galaxies are galaxies that emit large amounts of energy from their nuclei, typically far more than can be accounted for by the light emitted by their stars. This excess energy is thought to come from accretion of matter onto a supermassive black hole located in the center of the galaxy. As the matter falls into the black hole, it heats up and emits radiation across the electromagnetic spectrum, from radio waves to gamma rays. Polar ring galaxies are a type of galaxy that are characterized by a large ring or disk of gas and dust that is perpendicular to the main plane of the galaxy. This ring is thought to be formed from the accretion of material from a companion galaxy or by the tidal disruption of a smaller galaxy that has been absorbed by the main galaxy. The ring can also contain stars and star clusters, and it often rotates in a direction that is opposite to the rotation of the main galaxy. Starburst galaxies are galaxies that experience a rapid burst of star formation, producing stars at a much higher rate than normal galaxies. This burst of star formation is thought to be triggered by a variety of mechanisms, including interactions and mergers with other galaxies, gravitational instabilities, and the inflow of gas from the intergalactic medium. The intense star formation can be observed having strong emission lines, infrared radiation, and radio emission. Compact galaxies are galaxies that are much smaller in size than typical galaxies, but are still relatively massive. These galaxies are often characterized by a high surface brightness, which is a result of their stars being packed into a smaller region of space than in larger galaxies. They are often found in dense galaxy clusters or other regions of high galaxy density. Ultracompact dwarf galaxies, UCDs, are a class of extremely small and dense galaxies that are intermediate in size between globular clusters and dwarf galaxies. UCDs typically have masses ranging from tens of thousands to several million solar masses, and are characterized by high surface brightness and a high stellar velocity dispersion, indicating that they contain a large amount of dark matter. UCDs are thought to form from the tidal stripping and disruption of larger galaxies, such as elliptical galaxies, or from the merging of multiple globular clusters. They are often found in the halos of larger galaxies. Giant elliptical galaxies are the largest and most massive type of galaxies in the universe, with masses ranging from a few hundred billion to over a trillion solar masses. They are characterized by a smooth, featureless appearance, and are typically found in the centers of galaxy clusters or groups. Giant elliptical galaxies are thought to have formed through the merger of multiple smaller galaxies, resulting in a large, spheroidal structure with little to no ongoing star formation. Seyfert galaxies are a type of galaxy that emit intense radiation from their centers, often from powerful jets of material that are ejected from the central region of the galaxy. This produces intense radiation and magnetic fields that accelerate charged particles to relativistic speeds. Radio galaxies are Seyfert galaxies that emit large amounts of radio waves. Here are a few types of galaxy clusters. Galaxy clusters are collections of galaxies held together by gravity. They are among the largest known gravitationally bound structures in the universe and can contain anywhere from a few dozen to thousands of galaxies, along with large amounts of intergalactic gas and dark matter. Cool core galaxy clusters are a class of galaxy clusters that are characterized by the presence of a cool, dense core of gas at their centers. This cool gas can have temperatures as low as a few million degrees, which is much cooler than the surrounding hot intergalactic gas that typically has temperatures of tens of millions of degrees. Void superclusters, also known as supervoids, are large regions of the universe that are relatively empty of galaxies and other matter. They are located in the vast cosmic voids that exist between the large-scale structures of the universe, such as galaxy clusters and superclusters. Filamentary superclusters are large, elongated structures in the universe composed of multiple galaxy clusters and groups connected by long, thin filaments of gas and dark matter. These filaments can extend for tens or even hundreds of millions of light years and are thought to have formed through the gravitational collapse of dense regions of matter in the early universe. Sheet-like superclusters are large, flattened structures in the universe that contain multiple galaxy clusters and groups arranged in a thin, sheet-like shape. They are among the largest structures in the universe, with sizes on the order of hundreds of millions of light years. Unimodal galaxy clusters are clusters of galaxies whose member galaxies have similar velocities, indicating that they are gravitationally bound to one another. In unimodal galaxy clusters, the galaxies are typically distributed in a roughly spherical or ellipsoidal shape, with the most massive galaxies located at the center. Bimodal galaxy clusters are a type of galaxy cluster that exhibit two distinct subpopulations of galaxies, one concentrated in the center of the cluster and the other distributed more uniformly throughout the cluster. The central subpopulation is typically dominated by massive elliptical galaxies, while the peripheral subpopulation is dominated by spiral galaxies. Trimodal galaxy clusters have three distinct subpopulations of galaxies. There's the central dominant population of elliptical galaxies, a surrounding population of spiral galaxies, and a population of dwarf galaxies distributed throughout the cluster. Green P galaxies are a type of small, compact galaxy with an intense green coloration that is caused by strong emission lines of ionized oxygen. Lyman galaxies, also known as Lyman alpha emitters, are a type of high redshift galaxy that are characterized by strong emission lines at the wavelength of the Lyman alpha line of hydrogen. Lyman break galaxies are a type of high redshift galaxy that are identified by a steep drop-off which is caused by the absorption of ultraviolet light by neutral hydrogen gas in the intergalactic medium of the universe. Diffuse galaxies are a class of galaxies that are characterized by their low surface brightness and lack of well-defined structure. These galaxies are often classified as either dwarf galaxies or giant galaxies, depending on their size and luminosity. Dwarf diffuse galaxies are thought to be some of the oldest and most primitive galaxies in the universe, with little ongoing star formation or active galactic nuclei. Giant diffuse galaxies still exhibit low surface brightness and a lack of clear structure. These galaxies are thought to have formed through a combination of mergers and accretion of gas. Dark matter deficient galaxies exhibit a low density of dark matter in their outer regions. These galaxies are characterized by their low surface brightness and lack of well-defined structure, and are typically found in low-density environments such as galaxy groups or the outskirts of galaxy clusters. The low dark matter content may be due to interactions with the surrounding intergalactic medium, which can strip away the outer regions of the galaxy and remove some of the dark matter. Another possibility is that these galaxies are the result of rare or unusual formation processes, such as mergers between gas-rich galaxies or interactions with nearby dwarf galaxies. Blue compact dwarf galaxies are small, star-forming galaxies that have blue colors and are rich in gas. They are often characterized by intense star formation in compact regions, which is thought to be triggered by interactions with other galaxies or by gas accretion from the surrounding intergalactic medium. Blue compact dwarf galaxies are typically found in low-density environments, such as the outskirts of galaxy clusters or in isolated regions of the universe. Globular cluster galaxies are galaxies that contain large populations of globular clusters which can number in the thousands or even tens of thousands. Jellyfish galaxies are a rare type of galaxy that exhibit long tentacle-like structures, resembling the trailing tentacles of a jellyfish. These structures are thought to be the result of the stripping of gas and stars from the galaxy as it moves through a dense intergalactic medium, such as a galaxy cluster. The process of gas stripping can trigger intense star formation in the trailing tentacles, leading to bright blue knots of young stars. Green bean galaxies are a rare type of galaxy that emit an unusually high amount of light in a narrow wavelength range centered around the green part of the electromagnetic spectrum. Satellite galaxies are small galaxies that orbit larger, more massive galaxies. These galaxies are gravitationally bound to their host galaxy and are thought to have formed from small fluctuations in the density of matter in the early universe. Ram pressure stripped galaxies are galaxies that have been stripped of their gas content due to their motion through the hot gas in a galaxy cluster. As these galaxies move through the hot gas, they experience a strong ram pressure that can strip away their gas content, leaving them unable to form new stars. Tidal galaxies are galaxies that have been deformed and disrupted by the gravitational forces of nearby galaxies, often through a process known as tidal interactions. These interactions can cause the galaxies to stretch and distort, and can even lead to the formation of long tidal tails of stars and gas. Puffy galaxies are characterized by their extremely low surface brightness, which makes them difficult to detect and study. They are also known for their large apparent size, which makes them appear to be much larger than typical galaxies of their mass. Puffy galaxies may be the result of a recent collision which could have disrupted the galaxy's disk and scattered its stars over a larger volume. Counter-rotating galaxies are galaxies in which different parts of the galaxy rotate in opposite directions. Typically, stars and gas within a galaxy rotate in the same direction around the galactic center. However, in a counter-rotating galaxy, there can be a distinct region within the galaxy where stars or gas rotate in the opposite direction. This can occur due to a variety of reasons, including the merging of two galaxies with different rotation axes or the accretion of gas with a different angular momentum than the existing gas. Thank you for watching. There are definitely many more types of galaxies. Let me know which ones I missed in the comments.